Hi everyone, welcome to March's security session. And this month we're going to be focusing on Azure Advanced Threat Protection. So you all know who I am. I'm Tom Wild. I'm a cloud solution architect at Microsoft, solely focused on security. And Gershon, do you want to introduce yourself?
Sure. Gershon Levitz. I'm a senior program manager on the Cloud and Enterprise Security Customer Experience team, focusing on helping customers deploy Azure Advanced Threat Protection, Cloud App Security, and Azure Security Center.
Awesome. Thanks, Gershon. So do you want to kind of walk us through the products and kind of set the scene?
Sure. So before we do that, let's actually just talk a little bit about some security realities that we've been dealing with over the last few years. The first one is that the number of median days is 99 days that attackers are sitting on a network before they're actually detected. And in a number of cases, the detection is not even happening internally from the company. It's happening from third-party sources, whether it's a bank or government agency or an ISP. So the attackers are sitting on our network for a long period of time before we're actually seeing that they're actually, before we are actually able to detect them. The next one, which is a little bit more also, it's a little scary, is in the sense of 81% of the hacking are related to breaches from stolen or weak passwords. So password health is really important, and being able to detect this, the use of these passwords is also important. And of course, these attacks actually have a financial cost to them, aside of them. Is yeah, Globally, it's hitting about $500 billion, $500 billion worth of impact in the global economy, and on average, it's about 3.8, almost $4 million that it's going to cost the company to deal with a security breach. I actually just recently read an article in Inc. magazine that small businesses that get hit with a breach, 60% of them are actually are not able to survive the breach. So for
Wow,
small businesses, it's really important to be able to detect what's going on.
that's scary.
Yeah, it is. And it's, not something that a lot of small businesses are focusing on. They just, so hopefully we can help them with that with advanced threat protection. So these are the things that are keeping people up at night who are working, for companies especially on the security side is, how do I detect the compromised credentials? So we saw before in the last slide that, 81% of these are coming from weak or stolen passwords. Well, how do I detect that happening on my network? That these credentials have been compromised. Um, and then how do I detect that an attacker is moving from machine to machine in my network? And we'll see that we actually have some really interesting, cool technology that will allow us to help us clean our network up, to make it more secure, to make it harder for attackers to move laterally in the environment.
Gershon, do you want to just explain kind of why hackers move laterally?
Right. So hackers are going to come onto the network on a compromised machine, and then in essence they need to learn the environment. And it's what they're trying to do is find an account, a machine that has a domain admin who's logged onto that machine. So they need to be able to move from machine to machine to be able to get to that machine. So they might, before they could actually get to a machine, that domain admin. There are tools that are actually out there that allow them to map this out in a visual nature. And us from security and internal IT, we're very much used to working in lists and not working in graphs, whereas the attackers are very much used to working in graphs. And we're going to see before we do the demo, we're going to see this a map that we can actually see a graph that we're actually going to be able to present to you to help you understand where you potentially have some weaknesses in your environment that you could go ahead and fix those weaknesses before they're taken advantage of.
Gotcha. And are they using the pass the hash and pass the ticket techniques to move across?
Yeah, and those are some of the techniques that they're actually using, and how do you detect that, and what tools do you have today that are actually able to detect that pass the ticket? And a pass the ticket is being able to extract the Kerberos ticket, which is used in the Windows authentication, to identify the user, How do I get that ticket? How do I extract that ticket and then move it to another machine so that I can impersonate that user? And then when I move it to another machine, I don't need to provide a username and password if I have access to this ticket. So what technologies are available to actually see that a ticket has been moved from machine to machine? And we're going to see how we could actually detect that using advanced threat protection. And, people are asking themselves, aren't these rule-based solutions that I have today, why isn't that enough? I have a firewall, I have a proxy, antivirus, and we're going to see that based upon what we've seen in the news and the media over the last few years, that these security tools aren't necessarily enough, and we actually need to be looking at things a little bit differently. So we have the changing security landscape. So continuing on that notion, threats are getting more advanced. Attackers are using built-in tools. Once they get onto a machine, they're using built-in tools to actually do some of their reconnaissance and to understand what's happening within the environment before they're actually using some more advanced tools. So we need to be looking at things a little bit differently and tracking things a little bit differently, that we're going to see what's happening. So let's actually see what an attack would typically look like. So user 0-day brute force attack. This could even be a user, clicked on a link, and we do have Office 365, protection, advanced threat protection that will help us with the phishing attacks. But nothing's perfect. Or if a user's connecting to his personal email, they might not have that phishing protection that's actually there.
Yeah.
And we are the weakest link in the security models. The user is the weakest link. So users are going to click on things, and then the account is going to be compromised, and then the attacker is going to start to move that laterally that we spoke about before, using pass the ticket or pass the hash techniques to move. Until they actually find a machine where they can actually compromise an account that has elevated privileges in the network. And up until this point, this could actually happen fairly quickly within the environment. And this is why we need to be able to see these techniques that are being used in the various phases, such as reconnaissance or lateral movement phases of within the attack. At this point, the attacker needs to find the data. So I know, I've been at Microsoft for almost 12 years now. Sometimes it takes me a long time to find information. And I can just imagine coming in for the first day within an organization, without any introduction, without any employee orientation, trying to find data could actually be cumbersome. And this is where the attackers are spending most of their time, that 99 plus days, is actually looking and for the data that they want to extract and steal. And then eventually they're going to find it if they're not detected on the network, and then they're going to copy that data off the network. And what we really want to in Azure Advanced Threat Protection is be able to protect and identify that the attacker is on the network very early on in the stages, and not wait for we see an anomalous amount of data being copied out to the internet.
Yeah, you want to know as soon as possible, really.
Yeah, let's get them as quickly as we can. Okay, so we actually have here, so Azure Advanced Threat Protection, or Azure ATP, is going to detect advanced attacks involving identities across your on-premise your on-premise Active Directory. We're also going to be, in the future, we're going to be adding in cloud directories such as Azure Active Directory to give us that protection of your user's identity across your hybrid environments. Because today it's not just users on the on-premise Active Directory or the users on the cloud, and in the Azure Active Directory, it's a combination of the two that we want to take a look at.
Yeah, people still have on-premises infrastructure, right, with Windows Active Directory. So this is kind of where we're looking. Is that right?
Yeah, that is right. So we're starting to see attacks happening coming in from the cloud to on-premise, and then on-premise onto cloud, and this is why we're we're moving in that direction also, moving in the direction where the attacks are actually taking place.
Gotcha.
So Azure ATP is going to help us identify these advanced persistent threats looking at behavioral models, looking at malicious attacks, and then also looking at known security issues and risks, and sometimes even being more related to hygiene. So one of the things that we look at is we can generate a report for you to list out the user accounts that are sending their passwords in clear text over the network. And this typically is caused by an appliance of some sort, either a router or a VPN server that's doing authentication against Active Directory, and it's doing it in LDAP simple bind. It's not necessarily an indication of a compromise, but it does make it easier for an attacker who's sitting on the network to be able to sniff out these clear text passwords and then reuse them. So we would just need to go back to that appliance and increase the security level so that we're not sending the passwords in clear text.
So that they could just use something like Wireshark to pick that up, right?
Yeah, exactly. So if they're sitting on the network, if they're already on the network, they could be using Wireshark to pick that up off of the network, and they'll see the password in clear text. And imagine if your domain admin signs into the network over the VPN, and that VPN is passing on his password to the domain controller in clear text.
Yeah.
So, we're trying to make the job a little bit harder for the attackers. We don't want to open up the doors for them. We want to try to lock things down as much as we can.
You don't want to give them the username and password straight away.
Yeah. So the Azure Advanced Threat Protection, so it's a cloud service. We'll talk about real-time detections. So we have detections I would say they're more near real-time. I don't think anything is real-time. We have the Azure ATP team has a team of security researchers that are dedicated to reducing our false positives, so making these detection algorithms as positive and only raising a detection when we have a very high level of confidence that an alert should be raised. We also give you the ability to provide you with post-breach forensics, and we'll see that you could actually go back and look at the entity, the user or the computer, and sort of see the different activities that were taking place before and after the alert was raised. And we also have the integration with Windows Defender ATP, which gives us the capability of doing deep endpoint forensics and seeing the processes that were going on and were created on that machine, either from the point of view of the user on the machine or the machine itself. We give you that capability of doing that.
That's a really interesting point that customers and partners are super interested in, that kind of bit where products talk to each other and add value to each other.
Right. So we could actually jump the first level of integration that we have with Windows Defender ATP is being able to move from the console, and I could actually even see if this entity, this user or computer has an alert in the other console and then move to it, or I could just very easily move to the console and do some more investigation in the other tool that's gathering, it's more EDR, the endpoint detection and response capabilities in Windows Defender ATP.
Yeah.
So let's talk about Azure ATP. So the benefit of having Azure ATP in the cloud is, we're going to get the benefits of the scale of the cloud. So there's another version of this product called Advanced Threat Analytics, which was fully on-premise solution where you would have to deploy a pretty beefy server to be the centralized management of ATA. So now you don't have to worry about that. It's everything. We're managing that for you in the cloud at scale. And of course, we also have that integration right over here with Windows Defender ATP. And we're going to use Azure ATP to monitor your on-premise Active Directory at scale. So we're going to see all the traffic to and from those domain controllers. We're going to do deep packet inspection, and then we only send up a small amount of the network traffic up to the service. So we have an agent that we can install on your domain controllers, and we'll talk a little bit later about how we can plan for that. So there's no additional hardware that's actually needed. We just need to go in, enable the service, create a workspace, and then we can start sending our data up to the service. The deployment of Azure ATP is probably one of the things we constantly hear from our customers. That is probably one of the easiest products to actually deploy. So there are a few things that we need to take a look of in terms of prerequisites, but the deployment of Azure ATP is something that can really be done even in a medium-sized organization in a few hours. We have what we call the attack timeline. This is very much, we brought this over from social media, from Twitter, from LinkedIn, in terms of being able to show you the progression of what was actually taking place within the attack within the organization. We try to provide you with all the information in terms of what we saw, what took place, and what resources might have been accessed after the fact of what actually took place. And then we actually have guidance on the internet, which we link to, that which can help you provide direction in terms of the investigation and remediation steps that actually take place.
So it tells you or guides you how to fix the issue.
Right. So we'll link. It's not showing here in this screen, but we'll have a link in each of the suspicious activities back to the documentation that will actually provide you, how do you identify what are the things to look for, and then help you identify if it's a potential false positive, and if it's not a false positive, what are the remediation steps that you should be looking at to remediate the issue.
Okay.
We also have a profile and a timeline for each entity, and when we talk about entities, we're talking about both users and computers and even groups. And we can actually see here we're actually also syncing the information about the user from Active Directory itself, and then we'll actually show you things that were actually taking place. So we could start out, we see the security alerts that were open, the computers that this user logged into, the resources that they accessed, and VPN connect locations that they actually connected to. And then if the user did a replication of directory services from this machine, we would actually see these. So we would actually also see where the users actually logged into. Over on the left-hand side, we see some basic information about the user, about the entity. And this is where we see there are 4 security alerts that we have open up. And this is the integration. So if I would click on this icon over here, I see here that I have this user actually has 3 alerts open in Windows Defender ATP. And now I could actually click on that, and it will bring me over to those 3 alerts in the Windows Defender ATP. And we'll see that in a demo shortly. And this is the lateral movement graph. So you see there's a page on the bottom that you can click on that shows you a lateral movement path. And this is actually really powerful. So we see here Samira, who's a sensitive user. An ATA will automatically classify users as being sensitive if they're members of a group that has elevated privileges in the domain. Domain administrators, the administrators, domain controller groups. So we could actually see, so we're actually treating those users a little bit differently in terms of the alerts and also in terms of building this lateral movement graph. Because
how does it know that, Gershon? How does it know that a user has more privileges than another user?
So it's based upon the group membership in Active Directory on premise. So when we have a regular user account, that when we deploy Azure ATP, that will do queries against the domain for the basic structure of the groups and the users and basic information about all of the entities in Active Directory. And then we build that map and we see which users are actually members of domain admin. And we'll even track it through nested groups. So if an attacker comes in and creates a group and adds it to domain admins and then creates a user and adds it to that group, we'll still see that change was actually made.
Okay.
Now, something else that we could actually do is we could actually now tag different groups and users to be sensitive. So the CEO is probably not going to have elevated privileges in the domain, but he probably does have a lot of access to a lot of very valuable information within the organization. So the CEO can theoretically also be a target. So I could tag the CEO as being sensitive, and then we could theoretically build the map to see which users, non-sensitive users, have access, to machines that the CEO is logging into.
Yeah, that's
So
interesting because that they if you get into a sensitive user's Outlook account or workstation, then the hacker might actually have what they're after, because
correct.
they obviously see a lot of confidential information anyway, so it might be job done for the hacker, right? So I think that's good that we can tag certain high value user objects to kind of be careful with.
Right, and we could tag right now. We could tag users and groups. And we're looking at being able to tag computers as being sensitive.
Ah, okay.
Okay.
So is that
So
sorry, Gershon, is that kind of like what we're seeing on the screen? Is that like the Bloodhound tool that is commonly used by hackers? Is it kind of a similar?
yeah, that's exactly right. So this is the Bloodhound tool, the tool that builds that graph, that visual representation that I was talking about before. And what we're doing here is we're sort of building the same visualization for you, but for defensive purposes, so that you could be able to see where you have this overlap of a sensitive user on machines where there are non-sensitive users who have local administrative privileges on those machines. So let's walk through this example here. So we have Samira here, who's a sensitive user. She's a global IT manager, so she's probably a domain admin potentially. And we can see that she's logged on to this Redmond WA dev machine. What we also see is that there's a Contoso all user group that is also a local administrator on this machine. There are 39 members in that group, and one of those members is actually Oscar. And we actually see that Oscar is actually logged into the Redmond WA Dev 2 machine. And on this machine, there's actually two groups that are local admin, and it's Contoso All, which we saw before, and also the Contoso IT. So now, theoretically, anybody who is a member of Contoso IT can log into the Redmond WA Dev machine and potentially compromise Oscar's credentials. And at that point, when Oscar's credentials are compromised, then the attacker could do a pass the ticket, and connect to the the Redmond WA Dev machine. And once they're on that machine, they can then theoretically compromise the credentials of Samira, and then they have domain admin privileges within the environment.
So that's because Samira is logged on to that same machine, right?
Because Samir is logged onto the same machine that Oscar is logged into. So the question that this organization needs to ask is on a machine that Samira is logging into, why is Contoso All a member of the local admins group? And
Yeah.
this could be just a configuration error. It could be somebody was doing some testing. But if now we look at it and we discuss internally with the customer and say, Contoso All really doesn't need to be a member of the local administrators group on that machine. We could just remove that group from that machine, local admins, and now we've just removed that ability for somebody to compromise Samira's credentials.
That's so interesting that just the local admin, membership can screw you over.
Yes, yes, it is, and this is some of the things that we just need to look at, and it's really hard to visualize this just by creating a list, because it's going to be like, okay, let me go to this server and let me see what are all the groups, or what are all the members of the local administrator group. Okay, Contoso All. Okay, who are all the members in that group? Okay, now let me map that out to all my machines now. It becomes something that becomes really hard to do, and then build those lines between all the different objects. Here we're actually building this visually for you. It just makes it so much easier to visualize, and to potentially see where there might be issues, and where we can make the environment more secure by just through a very easy visualization. pictures
Yeah,
worth a thousand words. So
that's smart.
yeah, so this is something a lot of customers have been really like eye-opening for them when they first seen this. So this is quickly. I'm not going to spend a lot of time here. I just wanted to. These are the detections that we have in um, Azure Advanced Threat Protection. Again, we're starting from the different phases: reconnaissance. Um, you could look at our documentation and get a little bit more information in terms of what are each one of these attack methods actually can do. Um, one of I'll highlight a number of them is one I mentioned we have passwords exposed in clear text, which is a report. But we also have the ability to create a honey token. So this is just a user account in the domain that should have no network activity. And you could give it a name that would give it the allure of having high level privileges. And then if you would see activity for that, if when Azure ATP sees activity, network activity for that user account, you would raise an alert and say, hey, this is an account that should have no activity and we're starting to see activity. It's almost like it's like a honeypot for user accounts on the network. And of course, we have the pass the ticket. So when we see when a Kerberos ticket was issued to one computer being used on another ticket. And then the domain dominance. So this is actually a phase where once I've gotten I've compromised their credentials, well, that Kerberos ticket is usually only good for a period of time. And also, Samira is going to change our password every 30 days or 45 days. So at some point, I'm going to have to go back. I don't want to have to go back and redo all of this work again. So there are different things that the attackers do, and one of them is creating a golden ticket. And I like to think about this as being the golden ticket from Willy Wonka and the Chocolate Factory. Is like you got the golden ticket and you got access to the chocolate factory, for as long as you wanted. You just felt like a kid in a chocolate factory. So this is the same thing. He's like, I could create a Kerberos ticket. Once I've gotten domain admin privileges, I could create a Kerberos ticket that's good for very long period of time. So this way I don't have to worry about it. I always just use that ticket and I have access to the environment. And in Azure ATP, we could actually detect that based upon comparing it to the value in the domain of how long a ticket should be used. And if we see a ticket being used for longer than that, we will raise an alert for that. And we'll see an example of that detection in the demo of the console.
So that kind of monitors if you create like a master key.
Correct.
So how long are tickets normally valid for? Is it 24 hours or?
By default, a Kerberos ticket is good for 10 hours. And it usually you can renew, they will auto renew for a period of time. But when attackers would create these golden tickets, they're typically created for 20 years.
Right.
So, so with that, let's actually jump into the Azure ATP console. We'll see a little bit of what the console looks like. But before we do that, I just want to go into and say, okay, what's our environment and what are we going to see in the short console demo? So we have three computers. We have our domain controller, we have the victim PC, and we have the admin PC. We have Jeff, the victim, whose machine is going to be compromised, and we have Nuxty, who is the domain admin, who's the prize who we're looking to get at. And we also have Ron, who's our help desk user. And the help desk group is a local admin on both of these PCs. So what's going to end up happening is, the Jeff's machine is going to be compromised. The attacker is going to come in when Jeff brings the computer back onto the network. The attacker is going to try to start doing some reconnaissance. He's going to try to maybe some passwords of the domain administrators. He's going to see he doesn't get anything. He's going to, do something to the machine that Jeff's going to call up the help desk and say, hey, my machine's slowing down or something. And help desk will connect to the machine remotely. And then the attacker is going to compromise Ron's credentials. And then once he has Ron credentials, he already knows that Ron also is an admin, local admin on the admin PC. So he's going to connect to that machine and then compromise Nuxty's credentials. And even just by looking at these three machines, it's, building that map might be a little bit hard. But with Azure ATP, we would actually see a map similar to what we saw before with Samira, but this is really just on two machines. So we see that NUC is logged onto the admin PC. We see that the help desk is a local administrator on the admin PC, and we see that Ron's logged into the victim PC. So all the attacker needs to do is to get Ron, somebody from the help desk, to connect to the victim PC, and then in essence, it's game over. So let's actually see what this looks like from the console. So here we have the Azure ATP console. So it's a very simple console to look at, and we see all the different alerts that we actually have in here. And again, a reminder: we want to try to understand and alert that the attacker, detect that the attacker is in the network as early as possible, before they're actually able to do any damage. So let's actually start here. We saw reconnaissance using DNS. So one of the techniques that attackers typically are going to use is they need to build out a map of the environment. So they'll try to do a zone transfer. In this case, we saw the zone transfer coming in, and we alerted on it, and we can actually see and tell you that the attacker did a zone transfer request for contoso.com, attempted it once, and that the connection was refused, which is a good thing. It means your DNS is configured properly, but still the question is why is somebody doing a zone transfer request from a non-DNS server?
Yeah, to highlight something that, an admin might be trying something, but it's unusual, so you should be looking at it at least, right?
Right, we should be looking at it, and if we looked at it and saw who was on the victim PC, we would then be able to then say, oh, okay, we'd call up the admin maybe, and then or the user and say, hey, did you do this? And then we would then be able to say yes or no. The next thing we see is another reconnaissance technique called SMB session enumeration, and here this is a technique that there's a tool that allows you to enumerate sessions against an SMB connection, so a file share. And all users, when they log in, they actually connect with an SMB connection to the domain controller for the GPO and login scripts or files that need to be installed. So here we actually see that there was a session enumeration that was run by Jeff, the victim, on this PC. And we actually see that he enumerated two accounts, his own account, is what's connected to the domain controller. And he now knows that there's a user, NUC, who logged in from this PC. And here's the link that you could actually click on over here to actually learn about more about the SMB session enumeration detection. And we'll take a look at that in a second. So now we actually know that the victim PC did a zone transfer. And we also know that from the victim PC, we actually also now did some session enumeration. And then we actually saw that there was a reconnaissance using directory services query. So here, this is an interesting one. This is just using built-in tools, net group or net user, and we'll actually enumerate the members of those groups or the details of that group. And this is something, again, sensitive accounts shouldn't be happening. There's no real reason. There are some security tools and there are some applications that might have been written to do this, but we actually try to learn what is the normal usage of this command so that we can reduce the number of false positives. So they queried information against 8 sensitive groups and enumerated all groups in the domain. Enumerated the queries against 8 sensitive specific groups, so we could actually see these are the groups that it actually enumerated, so it knows everybody who's in all of these groups. So actually now the attacker is starting to build a map of which users they actually need to target. And then on the next one, we actually see honey token activity. So this is this customer configured Lydia to be a honey token user, and somebody tried to log in to the victim PC as this user, and we're raising that as an alert. Again, bringing high quality alerts so that we can actually identify that something's happening on the network really before they actually could cause any damage. And this would give us the capability now of being able to go to that PC, and whether using Windows Defender ATP or other tools to be able to then go ahead and investigate and hopefully identify and remediate and get the attacker off the network. And then we see a suspicious authentication failure from the victim PC. So here we're seeing, that they tried to log in, over 300 times for 3 accounts. And hey, one of those accounts is Lydia, which was the Honey token account, and it's also a sensitive account. And if we click on sensitive over here, it should tell us, let's see if we could do that again. It should tell us why Lydia is sensitive. So it's a member of 3 different groups. Let's actually quickly go to Lydia's account. And then if we click on the sensitive over here, we'll actually see it's a member of 3 groups. And that shows us which groups that the user is a member of that it is considered to be sensitive. And if this was a user, if you remember, we talked about being able to tag the CEO. So if this was the CEO that we had manually tagged as being sensitive, it would say the reason why they're sensitive because they were manually tagged.
Right.
Let's actually go back to the attack timeline.
So these are all medium level alerts at the moment, right?
Correct. The things that we need to be looking at and that should raise our attention, that we need to investigate what's going on in there. And then we could actually see the pass the ticket that was taking place. So the attacker got Ron to connect to the machine, and we see actually in here that there was an unusual protocol implementation, from the victim PC, so that the attacker sort of extracted Ron's credentials and then created a Kerberos ticket in an unusual way that didn't meet the standard method that could actually be used. And then that the pass the ticket that actually took place. So Nuxie's Kerberos ticket was taken from the admin PC and was actually then copied to the victim PC and then used to authenticate against the domain. And then it was initially used to do an LDAP creation query against the domain. And now at this point, the attacker is now, Nuxie, who's a domain admin, and now we could actually see, well, they did some remote execution. This could be a remote WMI or PS executive, and they're actually, either installing some command and control software or maybe skeleton key, or some other things that might be creating user accounts and groups that we have in there. And one of the things we actually see is that there's been, some malicious replication of directory services. So we saw a computer that is not a domain controller try to do a replication of directory services. Now, most of the customers are probably running Office 365 today, and they have Azure Active Directory, so they're doing some sort of syncing of their directory up into Azure Active Directory. So this is an alert that we'll probably see almost immediately after installing Azure ATP, but we do have the ability to go in here and close and exclude this entity so we won't see it anymore if it is a case where it is the Azure Active Directory tool. So we would call that like a benign true positive. So it's actually something that we saw, but it's something that you want to allow on the network, and you have the ability to exclude that from raising additional alerts in the future.
Right. And is that excluding the machine or the AD Connect process or something? What's it actually doing?
So in this case, it would actually be excluding the machine that the Azure AD Connect tool is running on.
Right.
And each detection, the exclusion might be a little bit different.
Right.
And then we have a detection. We're monitoring the group changes to the sensitive groups, and then we could actually see that somebody actually made a change to the sensitive groups. So Nuck added a user Monica Rush to the administrators, and then we actually are providing you with a reason. So NUC added Monica Rush to the administrators, although NUC was not observed modifying groups during the 11 weeks prior. The last modification was on Saturday. In the last 2 days of modification, before the modification, he was logged in from these following two computers. We're trying to give you background and evidence in terms of to help you with that investigation.
That's interesting. So the fact that something unusual has happened, basically, that you should look into.
Right, right. So we need to now look deeper into Nuxie's account and see what was going on within the environment. And here we could actually see where they logged into, what they requested access to. So there's a lot of information that we could actually see. And of course, we could actually then see around the suspicious activities what was actually going on.
That's interesting stuff.
And then here we have the golden ticket, so we could actually see that the attacker created a golden ticket for Jeff's account. This way you can log in no matter where. So we could actually see that Jeff's Kerberos ticket was used over a period of 11 hours, which exceeds the maximum of 10 hours. And we could see when it was first used and when it was last used. And then we could actually also see where the ticket was used, what it was used to access, and where Jeff was that last logged in. And now if we look at the victim PC, we could also see, when did Ron log in, when the expiration for the account. And then we could actually also see over here, we have the integration with Windows Defender ATP. So there's a one high alert. Let's actually click on that. And now we're going to investigate. Now we're moving to that investigation of the machine, and where we have Windows Defender ATP running, gathering all that valuable information in terms of process creation and access and integration with Office 365 ATP. And here when this pops up, we could actually see, oh, wait a second.
That's not good. Mimikatz.
Mimikatz not good. We could see a suspicious file was observed. We could see, so really very quickly, without even talking to the user, we could actually see what was going on that machine, and what Windows Defender ATP can actually show us in terms of what's going on. So we really have that capability of being able to now integrate and share information between our security products.
Yeah, I think that's kind of such a strong proposition that you've got, a post-breach detection to do with a device talking to, a Windows Active Directory breach detection system, and they're working together to kind of share information and just enable you to understand what's going on a hell of a lot quicker.
Yeah.
So that's that golden ticket, that's the one that you never want to see, right?
Well, there's a lot of things here we probably don't want to see, but yeah, if we see that golden ticket, that's definitely something that we want to take a look at and understand, why is that happening within the environment. Okay, let's just, I know we've been talking for some time now, but just wanted to talk a little bit about the architecture that we actually have for Azure ATP. So we actually have two flavors that we can actually deploy Azure ATP. I spoke about the agent, so that's installing the agent on the domain controller. We're going to inspect the network traffic, and we're going to look at a number of Windows events directly on that domain controller. We extract only the information that we actually need around the authentication protocols, but we're going deep into each of these protocols. We're going all the way through layer 7 on all these protocols. We're not stopping at layer 3 or 4. We're really going deep into the protocols. And this is where we're extracting the ticket information and the IP address, and we resolve that IP address to a computer name and we can dive deep into that in another session if need be. And then the sensor sort of extracts that information and sends that to the Azure ATP service.
How does it do
Um,
that, Gershon? Like, is there some type of encryption, or do you need a
yeah,
VPN or express route, or is it compatible with all?
so right now we're doing the SSL connection over to the internet. So the sensor will need access to the internet. So the star.azureatp.com, atp.azure.com. Um, and you can open that up in a proxy. So if you have a web proxy, you can very easily open that up for the sensor. Um, the access to the console is just through the internet. You would go to the portal for Azure ATP, and you would log in, and you would get access to your information. When Azure ATP does raise an alert, you can actually send that notification through email. You can send an email to your stock team or the security team that an alert has been generated by Azure ATP. And then we could also forward the information to your SIM. So this will also work with the sensor, where we designate one of the sensors in the deployment as being the connector to your on-premise SIM, so that you can use your SIM. If you're using your SIM as your single pane of glass, you can continue to do that.
And you've also got
The
an arrow going both ways in that seam, right?
Yeah, so if you're using the standalone sensor, so let's say you don't want to install an agent on the domain controller, but we still need access to that network traffic, so we could actually do that via port mirroring. So we would set up port mirroring for the domain controller traffic to a standalone sensor. Um, but since we don't have access to the Windows events that we need, we can either do that through Windows event forwarding directly from the domain controller to the standalone sensor, or if your SIM is already collecting those, we could actually send them directly from the SIM to the Azure ATP standalone sensor.
Cool.
So,
And if the security operators monitor all their alerts from the seam, then they can get Azure ATP alerts as well hooked in, right?
correct, correct, correct.
Awesome. And in terms of like kind of Active Directory architecture, is there a limit on the number of domain controllers? Is there a limit on the number of forests? Is it
So,
multi-forest compatible?
So right now in Azure ATP, each forest would need to be in a separate Azure ATP workspace. We are working on multi-forest support. You know, it's a big challenge, and something that we're working on to solve. So right now for each forest, it would be looking at a separate workspace. But if you do have that SIM integration sending the notification to the SIM, then you can use your SIM as your single pane of glass, and then filter your alerts directly from there.
Gotcha. And I suppose with ATA, the on-premise version, there was kind of quite a lot about infrastructure kind of requirements and estimating how much kind of CPU, RAM, and disk you need. Do you need to go through a similar process for Azure ATP?
We need to go through a similar process, but it's a lot less. There's a lot less in terms of infrastructure needs, and for two reasons. In ATA, we had a component called the ATA Center, which in essence did the same thing as the Azure ATP service. This is where we were collecting the data, the detections were being run. This is where our database was, so you can imagine in bigger environments, this would actually be a fairly hefty machine that we would actually need. Also in ATA, instead of a sensor, we have a gateway. And that gateway was rewritten totally from scratch in the sensor. So the parsing platform in the sensor is totally rewritten, and is a lot more efficient. So we can actually, we used to have limitations on the gateway of 10,000 busy packets per second on the domain controller. For the lightweight gateway on the sensor, we're talking about up to 100,000 busy packets per second, with a lot less resources that are actually needed.
Gotcha. Okay.
That's actually a good segue into the resources that we actually have. So the first thing is Azure ATP is part of the EMS E5 licensing suite. So if you don't have an EMS E5 license and you still want to try this out, you can actually get the 90-day trial through the EMS E5 trial. There's also the Azure ATP documentation site that actually has a lot of information in terms of the prerequisites of the deployment and how to walk through this. We will be adding some videos in the near future for that. And then we have the sizing tool. The sizing tool is really just that tool that I was just talking about that will actually just look at, it's a tool that runs for 24 hours and it really looks for and understands what's the traffic pattern in a 24-hour period and figures out what's the busiest 15 minutes. And then from there calculates what would the resources be needed for the sensor. We don't need to worry about resources for the cloud because that's part of the service that we're actually providing for you. And the last resource that we actually have in here is the Azure ATP Tech Community. So this is an online community where you can, go on board and ask questions, and it's monitored by, the product group teams, by my team, the CXP security team. It's a way of interacting with, the product group and the community as a whole.
Awesome. Thanks, Gershon. Kind of last question. Obviously, this is a really new product from Microsoft, Azure ATP. Kind of where do you see the advanced threat protection line going? Because for those that don't know, you've got Azure ATP, which sits in EMS. We've got Office ATP that sits in Office 365. And we've got Windows Defender ATP that sits in obviously the Windows sort of area. Where do you think the ATP line's going, and kind of what do you think the future holds for it?
So I think the future that we have with Azure ATP is one, continued integration with Windows Defender ATP. Windows Defender ATP actually has integrations with Office 365 ATP, so we will get those benefits from those signals coming from there. I also see Azure ATP looking and integrating with going back to that hybrid story of cloud identities and on-premise identities. So we'll be able to, with Azure ATP, connect into Azure Active Directory and start to get signals from there and be able to say, oh, the user typically was doing this on cloud authentications and requesting access to these cloud resources, and now is also compare that to what they're doing on premise and provide you with a single pane of glass in terms of the identity, security of the identity of the user, whether it's cloud or on premise.
That's cool. That's really interesting. So kind of even more integration for useful data.
Yep.
Awesome.
Yep. It's really giving you the visibility, using these tools and Defender ATP or Azure ATP, also the Microsoft Cloud App Security is giving us that visibility into things that were hard to really get visibility into beforehand.
Brilliant. All right. Thanks, Gershon. Thanks very much for kind of the interesting session on Azure Advanced Threat Protection. Do you want to just go to the second, if you can finish on the second to last slide, Gershon? Kind of question to everyone. Let us know if you found this session useful. Kind of you voted for identity security, so that's what we've got on. We can focus on cloud identity security if you want next time. Go to aka.ms/security session vote. Give us your feedback and let us know what you want for the next session. Thank you very much. Bye-bye.
Thanks.